All right, so let's go ahead and get started. So the plan for today is to cover a portion of 6.2 and a small portion of 6.3. And then on Tuesday, we're going to review, Thursday test, next Tuesday review, then final. This weekend, I will for sure have your review for the exam to you guys tomorrow, okay? As far as your review for the final, I also hope to have that ready for you guys this weekend, but it'll probably be closer to like Sunday, Monday type time, okay? All right, and if you guys want any help with the material when you're studying for your exam, I will be here on Saturday from 1 to 3. So it's a little unconventional, but it's just the best time I could get to be here. So Saturday 1 to 3 if you guys want to come by for any help. All right, okay, so we're going to talk about 6.2 first. So the main things we're going to talk about in this section, not how you spell it, is perimeter and area. So we're just going to talk for the last lesson a little bit about geometry. All right, so as a refresher, the perimeter is the sum of the lengths of a shape. Yeah, here we go. Sum of the lengths of a shape. Lengths of the sides. There we go. I knew I was missing some words. Sides of a shape. Your area is the amount of space inside the shape. Also, these definitions are like demathicized definitions, okay? So if you Google what is the definition of the area and what is the definition of the perimeter, it's not going to come up with this, okay? It's going to come up with something that uses math words, okay? But I think that this gets the main idea, and to me, these are easier to understand, okay? All right, so you also need to know 3 formulas. The area of a rectangle or a square, because it's the same formula, is the length times the width is the area. The area of a circle is area equals pi times the radius squared. So R stands for radius of the circle. Write that right next to it. And last but not least, you need to know the area of a triangle. And that area is equal to the base times the height divided by 2. I'm going to write what these letters mean over here. B is the base length. H is the height. All right, okay, so I'm going to erase these so we can do some examples. All right, so let's look at this shape. The lengths of the sides are 2 inches, 3 inches, 2 inches, 3 inches. It's like taking you guys way back. All right, and we want to find the perimeter and the area. All right, so to find the perimeter, all we have to do is add up all of the lengths of the sides. So our perimeter is 3 plus 2 plus 3 plus 2, which gives us 10 inches. If you're talking about an actual object that has units, make sure and put those units in your answer. And then your area, since this is a rectangle, we know that the area is length times width. So the area is 3 times 2. The area is 3 times 2, which gives us 6 square inches. The unit for area is always square something. So square inches, square meters, square centimeters, square goldfish, whatever it is, it's always square. Any questions about finding the perimeter and the area of this rectangle? If you've done homework with your children, you probably did this. All right, so now let's look at another shape. Let's look at this circle. All right, so we're not going to find the perimeter. We're just going to find the area. All right, so the radius, in case it's been a while since you took high school geometry, the radius of a circle is the length from the center to the edge. All right, so radius of a circle is the length from the center to the edge. All right, so if you guys remember from a few minutes ago, whenever I listed the formulas, the formula for area was pi r squared. Pi is just an irrational number. Usually in school, they have us round it to 3.14. All right, so for this class, you can either use the pi button on your calculator, or you can put it in as 3.14, or you can do what I'm going to do, which is just leave it as pi. So what that looks like is pi times our radius is 5. 5 squared, we know is 25. So we have pi times 25. This is completely correct, but it's non-standard notation. Generally, they write it as 25 pi. Yes, Dallas.
Does it matter if the exponent goes on the inside or the outside of the parentheses?
In this situation, no.
Okay.
Any other questions on how to find the area of this circle? All right, so we're going to look at triangle, a triangle. Use our last area formula before we move on to word problems with them. All right, so this triangle right here. a lot of times your height will be drawn as a straight line from the center point of your base up to the point of your triangle. That's your height. And your base is just what runs along the bottom. Okay? So I just put H and B so you guys would know what those numbers were. So if we want to find the area, our formula was base times height divided by 2. So our base here is 4. Our height is 6. And when you just do this in your head or in your calculator, you will get an area of 12. I didn't put units on this, I just put numbers. And so if there's no units, it's okay just to leave it as just a number. The only time you have to put units is if there's units in the problem. I always wondered why the units were squared, so I got to looking, and I read, now I don't know if this is super accurate or not, but what I read is the reason the units are squared is because back when they were first developing the idea of how to calculate area, they did it by counting how many 1 inch or 1 centimeter squares you could fit in an object. So when they say that many square inches, they're literally talking about 1 inch by 1 inch squares that'll fit inside. So that's why it's square inches, according to Google. All right, okay. Any questions about this before we talk about some word problems? We good? Okay. All righty. So here we go. First word problem. A triangular box needs to be covered. No, wrong problem. I got ahead of myself. A triangular box needs rope put around the outside edge. If 2 of the sides are 15 centimeters and 17 centimeters, how long is the third side if you only use 45 centimeters of rope in total? What you guys get that written down. All right, so we see here that we have a triangular box. So here's what I imagine it looks like. One side is 15 and the other side is 17. And overall, you can only use 45 centimeters of rope. And we want to know how long that side is. Okay? So since it's going around the outside, that's going to be our perimeter, all right? So that means our perimeter cannot be any more than 45 centimeters. But we know that in order to find a perimeter, we add up the lengths of all the sides. So I'm going to go ahead and set up an equation or a function like we talked about last week, or no, Tuesday, to figure it out. So we know the perimeter is 15 plus 17 plus x equals 45. We know the perimeter must be 45. So now we're going to go ahead and add our numbers together here, which gives us, what is that, 32. So 32 plus x equals 45. So for those of you guys who haven't had algebra in a while, whenever you want to get x by itself, because that's what we're solving for, if you have a number that's added to it and that number is positive, so we have plus 32, we're going to subtract 32 from both sides. And when you do that, you get 32 minus 32, which gives us 0 plus x equals something. Let's see, 13. And here, 0 plus x is just x, which is why that works. And so you get that your third side is 13 centimeters. If you don't want to do that with algebra, if you just want to write it like this and start guessing, that's fine. But it might take you longer than just doing these steps. Any questions about how to solve this one before I give you guys one to solve? We good? Okay. All right. Let me erase this here and give you all your word problem. I know. Well, I'm only changing a few words. I did it so it'd be really similar. Rectangular box needs rope put around if, let me get my thing so I don't mess it up. And if 3 of the sides are no, I just realized this is a giveaway to answer, but that's okay. 2, 2, and 3. How long is the fourth side? If you only have 10 centimeters of rope. And that should have centimeters here. 2 centimeters, 2 centimeters, and 3 centimeters. Okay. So you can probably look at this and know the answer, at least try to work out the math so that you have the process. I didn't realize when I made up this example. Oh well, it's all right, it happens. All right, Rebecca, let's start with you. What equation did you set up to solve for this?
I didn't really say anything else, but we see
Okay. Okay, Taylor, did you set up an equation?
I did.
Oh, well, thank you. What equation did you set up?
2 plus 2 plus 3 plus x equals 10.
There you go. Very good. All right, so Chance, what would be the next? How would we solve for x? What would be the step one for that?
Just add them together.
Add them together. So what does that give us? 7. Okay. 7 plus x equals 10. All right, Lisa, where do you? So what should we do next to solve for x? Subtract 7 from both sides. So how do I want to write this? I'll write it down here. So subtract 7. So we get x equals 3. Any questions about this one before we do some area word problems? Okay. All right. Oh, there it is. All right, so you guys will be pleased with this word problem's much shorter. A builder only has 14 square feet of wood to cover a rectangular hole that is 6 feet wide. What is the length of the rectangular hole? All right, I'll let you guys get that written there. All right, okay. So first thing we know, since he wants to cover it, we're looking for the area, right? Okay, so it doesn't say go around it, he says cover it. All right, so we only have 14 square feet and we need to cover it, so we know we need to look at area. They also tell us it's a rectangular hole. And we talked about at the beginning, the formula for area of a rectangle is length times width. So I'm gonna go ahead and just write length times width. They tell us that the wide, yes. So they tell us the width is 6 foot, and they tell us that overall the area has to be 14 square feet. So I'm gonna go ahead and plug in 14 square feet for A, and I'm just gonna put 14. We don't know what L is, but we do know that our width is 6. We have 14 equals L times 6. Now we want to solve for L. So Mariah, do you remember what we should do in this case?
Divide.
We divide. So since 6 is multiplied by L, and we want to be able to get rid of 6, we're going to divide both sides by 6. And the reason that works is because then that cancels there, and we're left with 14 over 6 equals L. That will reduce. You can leave it as 14 over 6. I'll write all the answers up here. So you can leave it as 14 over 6. You can rewrite it as 7 over 3. Or you can write it as a decimal, which I don't know what the decimal of 7 over 3 is. So if you put it in your calculator, whatever it pops out for you is fine as well. What is it, Taylor?
2.3.
2.3.
A little.
So any of those answers are fine. So that means that the rectangular hole is 6 feet wide and 2.33 feet long. Any questions about how we used our area formula to find the length? All right, so the your turn one is multiple choice. So at least you guys can guess. Nothing else, but I'm sure you guys will get it. All right, so let me get this erased and get you guys up here. All right, Samantha needs to buy a cover for her swimming pool. And I guess I should say circular. It's a round swimming pool. For her circular swimming pool. Her pool has a radius of 5 feet. Which of the following sizes should she buy? A, 80 square feet. B, 75 square feet. Or C, 30 square feet. Yeah, and they're having the same radius. All right, so Amanda, we are to you. What did you do first? If it's not an equation, that's fine. I just wrote that up just in case that was where you went with it. Okay, what did your notes say?
Find the radius, it's pi times radius squared.
Pi times radius squared, okay? All right, and what's the radius in this situation?
5.
5, okay? So pi 5 squared, which as we know is 25 pi from previous. All right, so that would require you to put in your calculator and know what 25 times pi is. Okay, so for those of you that put it in your calculator and figured out what 25 pi was it A, B, or C? It would be A. Okay, this comes out to be approximately, let's see, I didn't write it. What did you get? I just wrote that it was A. It's like 78 something. 78.54. So that's the area that she needs to cover is 78.54 square feet. So the only cover that will fit over it is the 80 square foot one. So it's going to be A. Whenever you're doing the word problems on the homework and on the exams, the main thing to remember is if it says around, use the perimeter formula. If it says over, cover, lid, anything where it would just take up all the space inside, use the area formulas. Any questions about this one before we start talking a little bit about volume? I see a lot of typing on the calculator, so I'm gonna wait for a minute. Did you get it, Taylor? Okay. Did you type in 25 pi? Oh, okay.
I cannot
Okay,
find it on
Let me,
the.
let's see if I can find it. Oh, here it is, right here. So pi is second, the little caret.
Oh.
So in case anyone's looking for pi, that's a good question. It is the second button, and then you hit the little arrow caret button that looks like this on your calculator. So second, and then the caret button. And I assume it's like that on yours, Tanya.
I got a little ice.
Oh, you have your own pi button.
Oh,
She has
fancy.
the $10 from Walmart. She's like, are your trash and her CIA form for your Walmart? All right. Are there any other calculator questions or anything like that before we move on to volume?
Calculators.
The other day, so my aunt, I gotta tell you guys a story about the calculator. My aunt, she is a wonderful lady, but she knows nothing like about math. Look at what I'm saying. And the other day I was working on something and I had to get my calculator out. And she looks at my son and goes, "Mommy's just not smart enough. She had to use her calculator." I was like, "Are you for real?" I was like, "You deserve to be glad Henry cannot understand you yet." But anyway, we all know that calculators are wonderful. They do not indicate the level of your intelligence. All right, so moving on to volumes. All right, so we're going to look at two particular volumes. Volume of a rectangular solid. I'll draw a picture too for these so you'll know what I'm talking about. Let L be the length. W be the width. And H be the height of a rectangular solid. The volume, or then, the volume is V equals length times width times height. And then one more volume formula, the volume of a cylinder. Oh, in case you guys are, promised you a picture, so I'll try to draw a picture here. A rectangular solid looks something like that. All right, so now volume of a cylinder. For a cylinder, let R be the radius and H be the height. Then the volume of the cylinder is V equals pi R squared H. And then I've got to draw a cylinder here. Okay. All right. And that's the best cylinder you guys are gonna get. It's not great, but it's not horrible either. It could be worse. All right, whenever you're done writing the definitions, glance up at me so I know it's okay to erase them. Okay, all right, so now let's do some work using these formulas. The formula that I actually really like, and this is a side note, is the volume of a cylinder. Because if you'll notice, we have that pi r squared part, and then we have the h. So pi r squared, we already know is the area of a circle, right? So whenever you look for a volume, what you're technically doing when you multiply it by the height is you're stacking a bunch of circles up on top of each other. So that's why you have the area of a circle times the height. But anyway, so now we're going, we want to find the volume of the figure below, which I'm going to draw. And if you're wondering, Kirsten, how did you learn to draw such beautiful rectangular solids? I would tell you, years and years of watching other people draw them well and then attempting. All right, so our height is 5. Our length is 6. Length, width, height. So length, width, height, here we go, is 7. So whenever you're talking about a rectangular solid, which side you label as the length, width, and height generally don't matter, all right, since they're all multiplied together. Now, if you guys are going to be engineers, then yes, it would matter because where the length is and height and width matters when you're actually building things. But if you're just drawing a picture and you need to, they give you a picture like this and they say, label the height this, the length this, the width this, don't lose sleep over trying to figure out which one's which. Just pick a side and go with it, okay? All right, so we know the volume for a rectangular solid is length times width times height. I decided that this was going to be my width. I decided this was going to be my length, and that this was going to be my height, okay? If you would have labeled them differently, it still would have come out the same way. All right, so that means volume equals length, which is 6, times width, which is 5, times height, which is 7, which gives us 30 times 7, which is 210. For volume, your units are always cubed. I didn't put any units for this, so 210 is fine. But if this would have been centimeters, then the answer would have been 210 centimeters cubed. The reason it's cubed follows along the same reasoning about why area has a squared unit. Whenever they were calculating the volume of solids like this, instead of asking how many 1 inch by 1 inch squares they could fit in a flat paper, they asked themselves how many 1 inch by 1 inch by 1 inch, so like 3D, 1 inch 3D squares, they could fit inside the solid. So that's why it's cubed, because you have a 3-dimensional object fit inside. Any questions about how to find the volume of a rectangular solid? I've also heard these referred to as rectangular prisms, and I don't know if there's a difference or not. So if you ever hear that, let me know. And let me know if there's a difference. I need to Google it. All right, okay, so let's look at the volume of a cylinder now. So I'm gonna draw a picture here. All right, so this cylinder's a little bit different than the rectangular solids because it does matter where you label. All right, so the radius is always going to be labeled here at the top, and it's going to go from the middle to the edge. Because like I said, a cylinder, the volume is just taking a bunch of circles and stacking them, okay? So your circle part, you want to make sure and label your radius there. And then your height is going to be how far it is from basically the bottom circle to the top circle. So we said that our volume was pi r squared h, which means for this cylinder, our volume is pi times r, which is 4. So 4 squared, h, which is 5, which gives us pi times 16 times 5, which gives us, sorry, who's in here, 80 pi. So I wrote that up there kind of fast. I'm going to pause here for a minute and let you guys look at it and see if you have any questions.
I don't know.
Mhm.
Okay, so like on top, that one thing, decimal form,
Okay.
on your test, does it mean decimal form?
It doesn't matter either way. As long as if you show your work, then I'll be able to tell what you're doing. All right, any other questions about this one before you guys attempt one on your own? Good, okay. All right, I'm gonna leave the cylinder up there, but I'm gonna relabel it. And you guys tell me what the volume would be. I'm actually gonna give you units this time. 3 inches and 7 inches. So please find the volume. Just a warning, Dallas, Tanya, and Summer, you guys are up next. So. Mariah, I have your test in my office. If you would go with me after to get it. Okay. Now I'm like, how unprofessional is it to go here? At this point, yeah. I'm sure. The first day, maybe not, but now, yeah. All right, okay. Dallas, are you ready? Okay, tell me what you put down for the volume. Like just what equation you used.
Pi. Which number goes with the R's?
The one up here in the circle.
So then it'd be 3 squared.
Mm-hmm.
I don't know.
Times the height. 7. Mm-hmm. Yeah, so times height. All right, so pi r squared times the 7, the height. All right, and when you work this out, Tanya, did you get what this worked out to be?
If I did it right, I don't know if I did, but I got 63.
63? Did anybody else get that? I'm seeing some shade. Yeah, okay, yeah, awesome. So 63 tied? Okay. All right, awesome. Any questions about how Dallas or Tanya got that? All right, okay, so now we're gonna do some word problems with them. The word problems are a never-ending flight of mathematics. All right. You are building a house.
Would the answer
Inches cubed. Yep, inches cubed. Building a house whose concrete foundation requires 4,774 feet cubed of concrete. If the foundation is to be 77 feet long and 31 feet wide, how deep, that's not how you spell deep, how deep will it need to be? I'm going to go ahead and draw a picture here. And it says it's 77 feet long and 31 feet wide. And we need to know how deep it will be. I'm going to assume this is not a traditional foundation because I don't know about y'all's foundation, but ours is hollow. So is that what you were thinking, Mariah? Yeah, that's what I thought this is a question directly, the wording, not the numbers, but the wording is directly out of your homework. And so when I read this, I was like, what? So I guess they mean like a slab. But my foundation's like those cement blocks you run around. But maybe they're from up north. I don't know. It's my excuse for everything. It's my sign language teacher's excuse for everything too. When she sees a sign that she's never seen, she thinks it's weird. She goes, "They're probably from up north." All right. So since they have given us, they said whose concrete foundation requires 4,774 feet cubed. Even if you did not realize, if you could not like imagine a solid foundation, that's a solid rectangular solid, we would know that they were looking for the volume purely because of this feet cubed. All right, if you ever see a unit in cube, they're talking volume. All right, so since they're talking volume, we need to think about the formula for the volume of a rectangular solid, which we already said was A equals length times width times height. And then we just need to plug in what we know and solve for what we don't. So that's not A, that should be B, my bad. So we know the volume is going to be this 4,774. They told us that the length is 77 feet and that the width is 31. And they want us to find the depth, or another word for depth is height. All right, so the first thing I'm going to do is just multiply these numbers together. So that gives me the equation 4,774 equals 2,000 387H. Whenever you have a number and then a variable next to it, and there's nothing in between, it is implied that there's multiplication there. If you would like to put a dot to show multiplication, that's completely fine. Either way, they both mean the same thing. So as before, when Mariah mentioned that since two things are multiplied, we can divide both sides by what that is. That's what we're going to do here. We're going to divide this side by 2,387, and then divide this side by 2,387. When we do that, this cancels and we're just left with H. So we have H equals, if you go ahead and divide that out, you get, of all things, 2. Which I guess makes sense because you wouldn't want like an 18-foot tall foundation. So I guess 2 feet is reasonable in my very limited knowledge of building. So, all right, any questions about solving this one before I give you guys one of your own? Okay, all right. Erase this here. And so for your turn, you guys are gonna have to draw your own picture. You're all on your own. Well, until we go through it, and then you won't be at that point. All right, so you need a fish tank. That can hold 10,064 inches cubed of water. If the tank is to be 37 inches long and 17 inches wide, how tall will it need to be? You guys have a few minutes there to look at that. Like I said, years of practice. Good thing is I don't give points or take away points based on the beauty of your drawing, so you're good. All right, about 30 more seconds, then we'll talk about it. All right, Rebecca, we're back to you. Do you want to draw your picture or do you want me to draw the picture? It don't, do you want to? You are more than welcome to.
This one didn't come out right, so.
Okay, all right, but just describe your picture to me so I know what, it's like drawing blind.
It's a rectangular.
Solid.
solid,
Yeah,
whatever.
yeah. I think they're the same, so it's fine. Okay, so,
Oh, that was the-
huh? It does look like a loaf of bread, doesn't it? Okay, let's see if I can make it straighter here. This is like, no, you're fine. It doesn't, that's funny. Okay, I think I'm gonna do it worse, but that's okay, we're gonna move on. What did you get? So, like, tell me where the label.
The volume, like the volume now first. Oh.
Okay.
No, length is 37.
Okay, where did you put the link?
Oh. I didn't get that.
So just pick a side.
Yeah.
That one?
I
Okay.
think that one.
Taylor's saying up here, so,
I didn't actually put it on.
all right, and then where did you put 17?
It's wide.
Yeah, so you put it here or there? It don't matter either way. Where do you want it?
Well, that one, the side would have to.
Okay. 17 inches.
Yeah, it works.
All right. Okay. So Taylor, she did the pictures, and now you got to do the formula. What did you write for your formula?
I should have switched.
With the 10,000 link.
Okay. Rebecca.
I wrote them backwards.
Oh, you wrote them backwards? Okay.
So it's 37 or equals.
Equals 37.
Times, or 17.
17, perfect. Times.
Times.
Yep. Perfect. All right, Chance, what'd you do after that?
37 times 17, 629.
629.
And then divided, and I got 16 inches cubed.
Mm-hmm. And let's see, 16. So it's technically just going to be 16 inches because
Okay.
the height, we don't do the cubes because remember, this is the length.
Okay.
So cubed is only for volume. So just 16 inches. All right. Did everyone get 16 inches? Does anyone have any questions about solving word problems like this one or any of the others we've done so far this evening? All right, okay, well, congratulations. You have finished learning all the new material you're gonna learn for quantitative reasoning. And look, all of you are still living. All right, so I'm gonna get that test review sent out to you. This test, like I told you previously, super short. It's gonna be short, but yeah. It should make you guys happy. You can come in, take and leave, and you have like a 20-minute class or whatever. So, all right, you guys have a great weekend, and I'll see you on Tuesday. And remember, tomorrow from 1 to 3, if you guys need me, not tomorrow, Saturday. Saturday from 1 to 3, if you guys need any help.
Will you be in here or your office?
My office. Mhm. If I'm not in my office, I'll be in one of those computer labs right there. Down on this one. I will give you a formula sheet.
Oh, yeah, that's one.
Yes, yeah. Hey, Summer, do they schedule those?
Yeah,
Okay, I'll give you my number. Okay, yeah. Oh, you have it on syllabus, you saw the syllabus, not on. Yes, okay. I know, right? It's a bond.
I guess it was 150, that's what Dustin told me. I didn't hear her. say
Oh,
it.
okay.
But I was like, I don't know, but it was like, I think 160 or something. I don't know, Paisley's was up at the 160s all the time. And I was like, it's a boy, and I was like, I doubt it.
I think I'm gonna have all boys, I really do. I think it's gonna be me and 3 boys.
I feel like I just want another girl, but like, I also want a boy, but I'm like, I just know I'm gonna get a boy and I have to spend all this money.
I know, that's kind of what I'm thinking. At first I wanted a girl really bad, and now I'm
Why
like,
is it
man,
cheaper than girls?
that is true. That is true.
I have like 4 coats of clothes that don't fit her anymore.
If you do end up having a boy, let me know because I have so much boy stuff. So, yeah.
I have a question, homework. When's the deadline of homework?
Next Thursday, November 21st at midnight.
On mine,
Yes, the Hawks on my.
next Thursday.
Mhm.
Okay.
Yeah, so you have a whole week. Oh, let me pause some stuff.